And we're back from the break with long task attribution. Patrick, do you want to share your screen?
Yeah, sounds good. Coming through okay? All right. So thanks everyone for joining. My name is Patrick. I know a few familiar faces here from my work on Chromium and Lighthouse over the past couple of years, but this is my first time directly meeting many of you. So I just want to thank you all for the invitation to share here at TPAC. Been a long time distant observer / beneficiary of this group's work. So it's great to put names to faces and an honor to participate this week. The context for this talk is a little bit different from many of the updates we've seen. It's not a formal proposal for a specific API or an update of anything ongoing, but rather just taking some time to share and explore how synthetic tooling, namely Lighthouse, has approached a very common web developer pain point, and if it might make sense to bring this model into a proper web platform API. So consider it a pre-proposal. And let's get to long task attribution in Lighthouse. First, a bit of background on what Lighthouse is actually trying to accomplish. So Lighthouse is a lab tool that captures performance metrics and identifies opportunities for developers to improve the page. What that means with respect to long tasks is that identifying the cause of main thread work is really critical for us. Long JS execution is usually the biggest culprit dragging down the performance metrics that we see in the lab. And knowing that a lot of work happened isn't super useful on its own. The first question they have after they get a low score or a low metric is why and how do I fix it? So devs need to know where to go and who to talk to and actually to make progress on their poor performance if they see something wrong. On the left here is an example of one of the Lighthouse audits that we have today that identifies which third-party scripts were responsible for contributing to the most main thread blocking time. And in order to produce a table like this, we need for every single long task to be able to identify who was responsible for it. So that brings us to our overall goal, which turned out to be quite different, actually, than typical breakdowns of execution time that you might have seen in traditional performance profiling. And it's important to keep in mind what we're actually trying to achieve with attribution here. For us, that means we want to find the proximate cause of work. In other words, we want to answer the question, why is this long task here at all? Which is actually pretty different from the question of why is this long task taking a long time? So attribution in Lighthouse is not trying to answer why a long task is long. I think for many of us on the team, that was a question we were more used to answering with typical profiling. But for Lighthouse, it's not about what's executing during a task. And it's not about what is making a long task take a long time, which are both important questions, but they tend to provide a little insight for typical developers on where to start an investigation on why work is occurring. And I bring this up mainly because the current focus of the W3C attribution definition in long tasks is focused around this question of what is currently being executed in the long task, as opposed to why is it there at all. So I want to walk through a couple of motivating examples. Some of these may seem obvious or trivial, but every situation here was at one point a very contested discussion with experienced developers on both sides before we reached consensus. So I think it's worth going through the progression that we experienced when trying to work out this attribution of long tasks. Quick definition of some important terms I'll be using that might be unfamiliar. Because the Lighthouse model is based on a Chromium trace, our terms are derived from those events. So when I'm talking about evaluate script, I'm referring to the initial task for the evaluation of a script when it first loads. So the macro task that executes on a script's initial payload. When I'm talking about self-time of a source, I'm talking about the time spent executing while that source is at the very top of the stack. So at the bottom of the slide here, you'll see a Chromium DevTools inspired flame chart that's breaking down where time is being spent. In this example, the top of the stack is at the bottom of the chart. So if we have one task that gets kicked off, that's an evaluate script, inside that, the first execution might be script.js, and then inside that, you might have child call frames or browser hook. So now we got some terminology out of the way, we'll start with a very simple case here of looking at a single long task from an evaluate script of a script called bad-script.js. And it's going to do some layout thrashing. So when it's executed, it's going to look at every DOM element and then alternate back and forth between setting and reading some dimensions. If you collected a performance trace of this sort of script, you're going to see a flame chart that looks something like the below. And it's going to have evaluate script at the top, that initial call frame, but most of the work is going to happen in these layout tasks that the browser is doing to relay out and then reread that width. So even if most of the time is spent in browser layout here, we would still say the bad-script.js is the reason that this long task is here. And so this kind of realization was, well, maybe self-time isn't exactly what we're looking for here. And our next thought was, well, maybe we can attribute by script self-time instead. But the problem with that is that many sites look very similar to the case we just looked at, except replace browser layout with, say, the work of a library. So in this example, we have a script that asks jQuery to do something 10 million times. And again here, even if most of the time is spent executing jQuery, bad-script.js is the proximate cause of this long script being here. So this gave us a clue, hey, maybe script self-time isn't exactly what we're looking for either. And maybe we want to be using whatever script was at the root of the stack. And this works well for synchronous cases like this, but real world pages tend to have a lot of async work. So for example, they'll schedule a set timeout or kick off an XHR, and then they'll ask the library to do something in that callback. So here, again, even though jQuery is at the bottom of the stack, in fact, it's the entire stack, nothing in bad-script.js ever actually executes within the long task itself, we would still say in Lighthouse that bad-script.js is the proximate cause of this particular long task being here. And so this suggested, well, hey, maybe we don't even want to look inside the task necessarily to find why it was here. Maybe we need to look for whatever script scheduled it or whatever is responsible for this task occurring. And so this, we finally have a case we might go too far. So now we have two scripts, middleman script that adds bad-script.js, and then bad-script.js is the same as before, where we have a set timeout of jQuery doing some work. And in this case, it's a little more up in the air. It's a little arguable whether middleman script or bad-script.js is actually the proximate cause of this long task being here. We have the open question of how far back up the chain do we go for causality. In Lighthouse, we stop at any evaluate script that has a URL that we could identify to a developer. So in this case, we would consider bad-script.js to be the proximate cause of this long task in the set timeout. Two main observations I hope we can take away from these examples. One is that if you take causality too far and you keep going back up the chain, you just end up saying that the document is the cause of all long tasks, which, while technically true, isn't all that informative for anyone. And the opposite direction, if you don't take causality far enough, you frequently end up pointing at the wrong script to begin an investigation. In fact, if you don't take causality anywhere, you might end up saying that the browser engine is the cause of all long tasks, because even if the script asked the browser to do work, it is the browser that took too long, conceivably, to do that work. So what we're really looking for with attribution is somewhere in between these two extremes. And we want to find causality that actually informs the developer on how they can make decisions on where to investigate and where to start looking to fix it. So I want to take a more practical look at how this actually works inside of Lighthouse. As a context refresher, so again, Lighthouse is a lab tool that records a Chromium trace while the page is loading. So for us, that means cross-origin leak concerns are not really a limitation for the analysis, and we do actually get bonus access to V8's CPU sampling profiler as well. So if we have a set of tasks that looks a little something like this, we have this long task at the very end that occurs in a set timeout. We would walk back and say, all right, well, who scheduled this particular set timeout? walk back to the previous set timeout. We would ask who scheduled this set timeout, walk back to maybe it was an XHR callback. And we would ask, all right, who fired this XHR, and walk back to that timeout. And then finally, we would say who scheduled this timeout and walk back to an evaluate script and say, bad script JS is the proximate cause of this long task that occurred way out here. So some pseudocode here for you on the bottom right. The general idea is that we walk up this tree of scheduling tasks until we find some sort of evaluate script that has a URL. And if none of that information is available, then we will fall back to whatever is at the root of the stack, which we saw is pretty helpful and does a better job than self-time alone. And if we don't have any of that information and the work was occurring inside of an iframe, we will return that frame URL instead of marking it unattributable. And this goes back to the idea that if you walk back causality far enough, you end up with document. In the case of iframes, though, document is somewhat helpful because it does narrow the scope a little bit from the page itself to where this work is occurring. And finally, if we don't have any of this information whatsoever, then we fall back to unattributable, and we say we don't know why this long task was occurring. So you might be wondering, in what cases are we able to actually successfully walk this tree? And so in set timeout and XHR, things work pretty much exactly as described. We're able to walk back up the tree and find the script that installed the timer or the script that kicked off the XHR. In some cases, though, there are some Chromium tracing gaps that we don't have perfect coverage of in Lighthouse to find the original instigator. So in fetch and event listener cases, we end up falling back to whatever is at the root of the stack. From what I understand, these aren't hard technical limitations. It's more of a, we haven't gotten to that point in implementing in Chrome tracing. And there are a few cases where we're not able to provide any coverage at all at the moment. And that's for DOM mutation cases. For example, if bad script adds a script element, we lose sort of any URL to be able to attribute it because this inline script doesn't have its own URL and we aren't able to trace back who installed it given the current Chromium tracing stats. And then finally, non-JavaScript async work is also difficult for us to track down at the moment. For example, the browser decides to spin up something or is executing async work that wasn't via one of these common JavaScript methods. We don't really know what script was responsible for causing it to spin up that animation, for example. So you might be wondering, how well does it work? Well, from the attribution perspective, we're able to come up with some useful URL in pretty much all of the cases. So 99.6 cases, 99.6% of all long tasks in HP Archive for August 2020 received attribution of some sort. It's fairly concentrated on particular types of usage patterns. So 96% of all pages have all of their long tasks attributed to some URL. And the 99th percentile is around 12% of their execution time is missing. When it comes to how accurate is it, we've been using this logic for a little over 2 years. And so far it's not very well to developer expectations. Our users are normally very vocal when they think something unfair has happened to assign particular script responsibility for execution. And we've had only real 2 major cases come up, one of which was a bug that we were able to fix pretty quickly. And the other is around this fallback case in terms of fetch and onload listeners. The other nice anecdotal piece about this particular approach is that previous attempts that we had as I went through the progression, monkey patching and polyfill scripts, particularly ones that instrument timing or are trying to do error catching, end up dominating attribution when you go with something like self-time or the root of the stack alone. So by being able to trace back to the original initiator, we're able to avoid that particular pitfall. And the other really nice attribute that helped us early on is that all of this attribution doesn't require any expensive intra-task timing information like sampling. We're able to only attribute based on the macro task relationship information between all of the scheduling. The 2 and not as good pieces of this we found so far, one is that scheduler scripts see inflated attribution if work is scheduled via variable mutation. So for example, if you have some master script that is running in a set timeout loop or a settle callback loop, and other scripts ask it to do things by pushing work to some sort of queue, then the master scheduler script is going to be receiving attribution for all of that work. Now, typically we see this as a problem when it's like a large SPA and we're not able to distinguish between its own scripts. This is the pattern that we see common there. But in Lighthouse, the most common use case that we see developers really appreciating this particular type of attribution is when it's distinguishing between first party and then all the different third party scripts they have on their page, which is pretty rare to see any like sort of master scheduler between unrelated third parties. The other piece is obviously, so Lighthouse is a lab tool that's gathering synthetic information basically only over load up until today. So we have this good validation that it matches developer expectations before any user interaction, but we have limited data to suggest how well it's going to perform in the interactive case once the user is interacting with the page and it becomes a little more dynamic. So that's how Lighthouse long task attribution works. And I really wanted to spend the rest of the time noodling on some of these open questions we have. First off, is this model of proximate cause that we have, does it seem widely applicable? How does it gel with other folks' understanding of how you should attribute work to particular scripts? Assuming that it is interesting and applicable, is this feasibly implemented cross-browser? Up until now, we've used Chromium Trace Events to be able to provide us this information. Is there anything maybe that might be different cross-browser that would make this sort of implementation really difficult? And assuming that that is all good and that it's widely applicable, would this model still yield developer value as a web API even after cross-origin concerns are taken into consideration? So I imagine this will have to follow a similar model to what Ulan described with memory, in that we're not able to leak any URL that isn't already known to the main page. But in Lighthouse, we haven't dealt with this concern because it's a developer tool that already has access to all this information. So given that the most valuable piece that we get out of this is learning these third-party URLs that are causing problems, how we want to ensure that whatever came out of it after we take those concerns into account is still valuable. So maybe if we wanted to start, I would love to hear people's thoughts on this first question, initial impressions of the proximate cause model, and how does that mesh with your interpretation of attribution?
Oh, so first of all, thank you so much. This has been super useful. I'm wondering whether the bits and pieces where we cannot attribute are fundamental or just implementation driven. In particular, you mentioned scheduler scripts and work being pushed from a queue. Do you see that kind of attribution? Like, do you think that kind of work can be attributed to avoid over blaming scheduler scripts? Or potentially, we also talked about something similar in the context of events. So if we have events that register some work that needs to happen post hydration, hypothetically, that is also something that we would love to keep track in in a similar mechanism. And so yeah, thoughts on that?
Yeah, I think the scheduler problem needs to be solved using a combination. I don't think you can solve it just by having smarter automatic attribution. I think some sort of developer annotation is kind of required to solve that particular problem, because the scheduler is potentially executing work of many scripts inside the same task. It kind of needs to be the one to say, okay, here is this work from this context or this work from this other context. So I definitely think it's solvable with additional annotations from the scheduler script. But at least I haven't come up with an idea of how to address that problem without their input, mainly because they're the one that knows how work is being scheduled, and sort of automatic attribution, even if it were heuristic based, feels like it would ultimately be much lower quality than if we were able to get some sort of annotation.
I did chat with the V8 team at one point about the feasibility of tracking what's mutating each variable and then what's reading from it. And somewhat unsurprisingly, they said that would be way too expensive. We can't possibly do that. You can imagine us having some kind of heuristic-based approach, perhaps, but we definitely can't do the sort of perfect thing.
Michael?
Yeah, I mean, first of all, this is fantastic. I was curious, you mentioned that you have access to traces and stack sampling, just the way Lighthouse does it, but how much of that does this actually rely on? It seems like the top level task attribution, like in terms of context, is information that's readily available. Perhaps in some of the fallback cases, you need access to the stack to know like the top level thing, but like how much is easy to compute and not necessary as a web standard versus what Lighthouse is doing like additionally with the stack sample?
Yeah, so you're right. The stack sampling is really only necessary. In fact, standard regular Lighthouse today doesn't have the stack sampling enabled at all. So we actually don't get that information as sort of like an experimental add-on to add more granularity to our attribution. So that 99.6 number we're actually able to get without V8 stack sampling enabled. So it's really kind of like a nice bonus to further narrow down what's happening. But you're right, all of the relationship information here is macro task relationships. With regard to how, the web exposed nature of all the individual relationship information, that might be too much to be able to expose each individual relationship. I imagine there might be a lot more information gleaned for being able to understand the relationship between all tasks of any length as opposed to only long tasks. So I would have some questions to answer there, but I think the fundamental idea of being able to track back the task relationships and only exposing the original URL or ID that the original page already knew seems much more realistic. And in the case of Chromium, they do already have this information in the trace. So I didn't implement it, but I'm assuming that it should be fairly straightforward to just also be able to emit that information for other purposes as well.
Regarding your last question and cross-origin concerns, I think that if we limit the information that is exposed to just the pre-redirect URL, this is already information that the page has or can obtain. So the pre-redirect URL is already visible to the page by multiple means. And then a page could stagger the loading of different scripts in order to figure out which one of them is triggering a long task and perform that attribution. Then it's not something that people can actually do in the wild in production, but for attack scenarios, that seems like something that people can do, and therefore this is already exposed regardless of the long task API just from set timeout timing attacks. So
can I go in another direction? I don't know if that's follow-up or so I think your talk was referenced already earlier this week in anticipation, both from the responsiveness topic as well as the SPA topic. And today you brought up the scheduling case where you might want developer annotations because the cut point, so to speak, isn't easy to identify automatically. But for responsiveness or soft navs, that's another potential cut point. And I think like I've heard you speak to this before, and you mentioned that it's possible that evaluate script is also happening in certain cases, like click handlers or something like that. But you can imagine developer annotating start points for soft navs or certain important interactions. And then rather than attributing long tasks back, it's almost like attributing from the start point any task moving forward, if that makes sense. So any future async work that is somehow in its chain attributed back to the start point, that's what you would consider proximate cause, I guess, which seems interesting from that perspective as well. Like perhaps we can use the same tactics for a different reason, like end-to-end responsiveness.
Yeah, it's almost like taking the extreme document example, but reapplying it to a specific point in time of the document, right? You can say, well, all work came from this particular version of the document, marking that point in time. That's an interesting alternative use case. The graph information itself is really useful for a number of reasons, and I'm excited to see what else comes out of being able to have this more readily available. I would love to hear any of the RUM providers, if they're tracking any long tasks and if they're doing any sort of attribution or anything that might be relevant here. How does this proximate cause idea gel with what you might already have today?
For Akamai's Impulse RUM, we are capturing long tasks in the wild, but we don't have any sort of automatic attribution. Our customers always ask, well, what do I do with this data? It can provide hints towards there's something wrong, but then they obviously have to dig into the tools and use Lighthouse and other things to actually get the information. So if there's more things that we could track from RUM to actually start pointing fingers, at least at a very high level, that just, it saves time. It helps the customer track what are the true culprits or not, especially over time. How does that change over time? How does it change on this one person's machine in this random country? It's all that kind of stuff. So, yeah, getting any more sort of information that we can beyond just what long task reports today is would make this kind of data way more useful. Right now, like, we capture it, but we don't feel super enthusiastic about it because we can't really tell much more than just this thing happened. The thread was blocked. So absolutely, one of our biggest requests about long tasks is just getting some sort of better attribution. I also would say, Patrick, you touched on one point around better attributing what some third parties may be doing on the page, and that in particular for what we do for RUM is we sometimes wrap top-level APIs, and the attribution that you're doing here helps stop pointing fingers at our own JavaScript, because it more smartly points to, well, what was the true cause of that API being triggered, not just the JavaScript that was in the middle happening to be the library of choice. So it's really cool to see that.
One other very unrelated case that kind of comes to mind is this sort of useful developer attribution is, I'm sure we've all had an error with a stack trace that is, largely useless because it points to some async click handler, et cetera, and being able to attach what script, installed that listener and where, I think would be also very useful. So maybe very unrelated and outside the scope of this perf group, but just interesting other cases for this attribution graph information.
Yeah, and our JavaScript error tracking has that same issue as well, absolutely.
So Patrick, you mentioned the second question is feasibility of implementation cross-browser. Have you tried to investigate on other browsers if it could be possible?
I have not. I would love to hear if these same concepts apply equally from the other browser vendors. My initial cursory investigation suggest that it would, and that perhaps the biggest sticking point might be the different coalescing of tasks and kind of prioritization and breakpoints that differ from the analysis that we do. But I don't have a very strong sense at this point whether this graph information is easy or difficult to obtain.
Okay, thank you.
So maybe that same question to other browser vendors. Any without any commitments, any hunches regarding feasibility of this?
My initial impression is this sounds a little difficult to implement and expensive, possibly, but I mean, beyond that, I don't immediately have any fundamental problems, but those are big hurdles.
Yeah, we're behind on log tasks, so this is really far out for me. I choose not to speculate here.
Thanks. Any other questions, concerns? In particular, so on the cross origin attribution bit, is that like, do y'all agree with my assessment of this not being new information, or okay, I guess, yeah, maybe we can point that question towards security folks to get them to sign off on it. Okay, so there.
I would say my next question would be, how could we best help in terms of what would be a reasonable next step for making this more concrete, if there is interest.
How about filing an issue in, or I don't know if there is one already in the long tasks repository. If you have a concrete API shape in mind, then that can help, but it's not necessary. Most importantly, it's just showing the use cases that it's trying to address that obviously are not being addressed by the existing API. And maybe if there are any security questions from how do we ensure that like bouncing across frames, the attribution is safe to expose? Like how do you reason about that if possible?
Thanks, sounds great.
Yeah, as Alex mentioned, I think this would be, it's certainly not cheap for us to implement either. And we want to have pretty clear answers to, for example, the question around once cross-origin concerns are taken into account, how valuable is this? I don't know whether it would be possible for us to just do sort of a quick tweak to the Lighthouse algorithm to take into account cross-origin concerns, and then we can stare at the data a little bit, or something along those lines. But having more data to gain confidence that this would be useful would make me much more comfortable saying it's worth further investment.
Yeah. The cost of this is also not super clear to me. I guess I wonder if Fulan is still here. Do you know who we can ask from V8 team about implementing this, or?
Hey, I'm still here. I think Simon may be the person, like he worked with stack traces like Peter Marshall, and Simon maybe helps to ask.
We also might want to talk to Scott Hazley on the scheduling end of things.
Sounds good. Thank you.
This might be naive, but given that every macro task already attributes its cause of scheduling, that's true, Patrick, right? Because it's already in the trace data without jumping through hoops.
Yeah, so this is all available with tracing enabled. I think part of the question is how feasible and what is the cost of maintaining that?
No, we don't enable tracing on real user devices, right? That's something on the lab. So that's the main question.
I'm just curious if the data that went into the trace was only computed in the cases where the trace was generated. So maybe that's what we need to check. But I figured that it was readily available data that was included in the trace, which is maybe incorrect. Yeah, fair.
Right. So we need to do more investigation to the feasibility in terms of performance. Yeah.
Cool. So with that, any other last minute questions, or shall we move on to the next subject? So, okay, with that, Andrew.
All right. Got to say, that's a pretty good segue. We saw the attribution. Now we get to see the samples. All right. All right. So, yeah, I'm going to be chatting a little bit today about the JS profiling API, JS self-profiling API, a thing that gets samples from the main thread, whatever you want to call it. So for a bit of context here, this is an API to sample client-side JavaScript. Continuing with the DevTools theme of the last few presentations, this gives insight into like what exact JavaScript is executing on clients' machines in pretty much exactly the level of granularity that you've come to expect from like local developer tooling. So the idea is like we have users in the wild running like maybe a few experiments, maybe running some wacky third-party code, and we want to figure out like why a given load was slow, and maybe attribution alone doesn't give us all of the picture. We want to dive deeper on a more like qualitative level. And so ergo, we wrote an API for it, and it basically is just a sampling profiler. We implemented it in Chrome, ran an origin trial in M87 to 80, got a lot of great feedback from partners, and found a few issues ourselves on Facebook. So everyone was happy. The API has been changed to require co-op and co-op, as we talked about. I think it's probably been months ago now. But as part of a step to ensure that, since this is like a very timing sensitive API and exposes like raw sampling timestamps, as well as potentially like stack frames from cross-origin resources, co-op and cross-origin isolation in general turned out to be a pretty great fit. Cool. And yeah, and there's a demo of the API on the right-hand side. Fairly straightforward. You throw in your sampling interval. The UA will decide what sampling interval it can actually best provide samples at. You'll do some work. It doesn't have to be all in the same macro task. It'll basically record until you call profiler.stop. And then you'll get a trace in a try format that's very similar to DevTools, which is a pretty effective form of structural compression that you can then send over to service for analysis, rip it apart, or do what you will. And here's just an example of the trace format. There's some more detail on the GitHub, which I should probably have linked in this slide. If you Google JS self-profiling, it'll show up. And basically, that's just making use of like common parent stack frames. Again, very similar to the way Gecko and Blink have their DevTools tracing. Cool. Any questions or ambiguities regarding like the API shape or anything before we move forward to some of the feedback? Thank you. That's great. Cool. All right. So yeah, the origin trial went pretty well. On our own side, we found a bunch of like pretty pathologically bad cases with performance that we wouldn't have seen just like with local profiling, especially since on our end we do serve different code to employees, and that was great. We shaved like I think on the order of like tens of milliseconds on certain interactions, and I don't have the numbers for page load, but I think interactions was like the primary use case where we found a lot of unusual things. And this sentiment was actually also shared by the Excel Online folks, who also ran their own origin trial for this and actually liked it so much, Edge now has renewed the origin trial. So yeah, one of the interesting things was that the focus on interactions in particular really highlighted the need for this API to be very performant. Since you can imagine if you're like, say, clicking on a button that maybe triggers a lot of work, you want to obviously commence that work and remain responsive to user input as soon as possible. And that can be a challenge since VMs often require metadata in order to perform this profiling. Like, for example, in Gecko's case, were you to use an API like this, it requires, with current architecture, recompilation of some bytecode, which is not ideal to do in response to a click. So I'll talk a little bit more about activation. In Blink, the story is a little bit better, sorry, Blink and V8, because all we need to really do is build up the code map to provide like a mapping of like, say, bytecode offsets and native code offsets over to source functions. But nonetheless, there's still work to be done, and we need to figure out when to do it. Cool. So yeah, this is basically just what I said. We talked about this in a prior call as well, and one of the ideas that came up was let's leverage feature policy, and that seemed really great. I was really happy with it, and then I found out that there's a lot of debate and strife over how feature policy should support certain worker use cases, which we think are pretty important to the API in particular, such as service workers and shared workers. So I think that's still like fairly contentious last I checked and blocked. And coupled with the fact that feature policy no longer has a disabled by default param, it was actually removed as part of the migration to permissions policy, sort of complicates things because we do want to be disabled by default. We want to have a surface where if like developers can profile very like meaningfully on a small subset of users rather than maybe perhaps negatively impact the experience for everyone by introducing that like warm-up time. So we had a few ideas for alternatives here. The most obvious one was just having script-driven warm-up, maybe when you can instantiate a profiler ahead of time, and with that profiler, it'll trigger like the buildup of this metadata. But one of the problems with that is that a lot of this work does need to be done on the main thread. And the trivial way to mitigate this, well, I won't say it has to be done on the main thread. With the current like user agents that we've looked into, it does require a lot of main thread work. And it's a lot cheaper to do this online rather than stopping the world and then rebuilding all of this metadata for every single function on the page. So that's not ideal. We could amend permissions policy, but that would require figuring out what to do with workers, especially, or we could just maybe keep it disabled for shared and service workers for now, and then explore it later if that turns out to be a use case that people care about. Or we could just cheese it and add a new header and just have the enabled status for a given script or like cross-origin isolated cluster be the intersection of JS profiling 1. So kind of curious folks' thoughts here. Yeah. I'm particularly curious as well if there's any precedent for any other APIs that might want to do this form of warm-up work, because digging through the various X policy specs seem to indicate that a lot of it was for just like very simple feature activation rather than we actually need to do this for performance concerns.
So what are the blockers for permission policy? Like, did you talk to Ian Cleland and like other WebAppSec folks about supporting that use case?
I've chatted briefly about the disabled by default use case with some people, but this is a while back. I don't think it was Ian. I think that I think the disabled by default stuff is fine, but the shared workers stuff I think hasn't been touched in a long time. But like, I definitely, I think that it makes sense to open up another dialogue regarding that.
Okay, cool. I can take an action item to spin that up.
Cool. That's great. But yeah, I guess, so yeah, maybe we should just move that offline then if it seems like permissions policy is the right venue to go about this.
I think so, unless we will find a fundamental reason not to go that route. But yeah, it would be good to have that dialogue before deciding that, we need something completely different.
Yeah. Cool. Sounds good to me. So that was the main contentious issue that I want to talk about today. I also want to solve the hardest problem in computer science. We've had some feedback that self-profiling isn't really that commonly used in an industry or as like an industry context. And we should probably figure out like a simpler name for the API, maybe one that made a little bit more sense. So I threw together some candidates, took a look at some other spec naming. I'm sort of partial to JavaScript sampling API. I feel like it encapsulates the fact that this is a sampling profiler fundamentally, and it does in fact sample JavaScript. Again, opening the floor if anyone feels strongly about this. Mostly just a bit of a nit, but thought it'd be fun to talk about.
Naming's always fun. When doing these exercises, I like to think, what would somebody who is not in this space, who hears about it in a hallway, what would immediately come to mind? And profiling seems bad because, like user profiles, like you can imagine identity being related to profiles. And so somebody could mistake that. Yeah. I don't know that sampling would be misused. I don't immediately hate it. Like, what would it be to give Costco food samples or something? I don't know. Like, there's no way to misunderstand it, maybe, but
yeah,
just something like being short and terse for experts is one thing to consider, but being very explicit so it's immediately obvious to folks who hear about it what it's trying to do.
Yeah, to answer Kareen's question, sampling was chosen primarily as it's sort of like intrinsic to the nature of the API. Like, I don't think there's many other like sampling-based APIs, maybe some in the performance timeline space. And I think JavaScript sampling itself is pretty unambiguous with regards to what it refers to. But that's a fair point that sampling in isolation maybe doesn't mean anything.
Hey, this is Mike from W3C. Just comment, I think I'm a bit surprised that the word self is not in any of these other candidates. The self part seems pretty important to me, at least, in communicating to the average web developer about what this is doing.
Okay, that's interesting because we had some conversations where people are actually confused at the self part in particular, which is hence what spurred this this idea.
Yeah, Mike, do you want to elaborate on why do you think the self bit is important here?
Because it's fundamental to the whole feature is that you're not using this. I mean, I think the fact that we don't sort of find that fundamental is because they're too close to it, but somebody else is from the outside. The idea that the application itself has APIs exposed to it that allow it itself to measure its own performance is kind of different from the rest of the things we do. I mean, maybe it's not that different to people who work on web performance. It aligns with other work in web performance work, but in general, I think for web developers, having that kind of mechanism exposed to the web application itself is a bit surprising, maybe. But honestly, it was just a comment. I don't feel that strongly about it, and I think probably you all have had more discussions with actual web developers about it than I have.
No,
So,
not necessarily. I was like, to me, like the what is self-profiling anyway comment resonated with me. So I was just
really,
yeah.
yeah, because to me that's like the whole thing is self-profiling. Like, I mean, yeah, it's to just the sense of it. This is not a close analogy at all, but sort of the idea of bootstrapping, that kind of thing, where you're having this system do something reflective, doing some self-reflection that normally I don't think is something that that we have a lot of other cases of. But then again, like I said, now that I say that out loud, I think that there is more of that kind of stuff in web performance APIs. But yes, self-profiling immediately means something to me, I guess, but maybe I'm just an oddball.
No, I mean, in the broader context of like full stack web systems, I think that it makes sense. Something like client or self definitely pinpoints it down, since you could have JavaScript on the server, JavaScript on the client, and it's sort of interesting. But in the W3C, or in this world at least, it's unambiguous that we're referring to the client. So JavaScript client profiler doesn't make much sense either. So there's some comments in the chat. JS sampling tracer. I think that's interesting, except I feel like tracing and sampling are sort of orthogonal in some ways, since tracing can refer to like measuring segments, whereas sampling is just like sampling. And performance profiler, I do like that, actually. That does seem to fit in with the other web perf working group APIs, though it isn't immediately obvious that we're profiling script. I know one of the asks that we actually did have is like, can we sample things like layout? Can we sample things like style recalcs and stuff like that? But performance script profile. Okay.
Does the API differentiate between like idle time and time spent in like recalc style or layout or anything like that?
So it does not, as it stands right now.
So it's just script.
It's just script, right?
Yeah, one small thing I noticed along the kind of tracing nomenclature is that I guess in the spec right now there is a profiler trace dictionary. And so I think for the same reason that you're not too keen about using the term trace, I think you might want to change just the name of that interface name, because to me, tracing is the same way. Tracing is kind of like instrumented profiling. It's not a sampling thing. So I think a smaller thing. To me, I mean, I think, sampling API, profiler API, to be honest, the candidates that you have listed here are pretty good. I think anyone who engages with the API is very quickly going to see that the result is samples. And if they were hoping for start-stop style payload, they will quickly realize it's not. So like, it may not be super critical. The API itself says defines that this is a sampling profiler and this is what the payload is. Perhaps more important is just kind of communicating the scope of what is being captured, which is basically JavaScript, just JavaScript, and not. And so to me, the priority would be, yeah, just communicating that it's just JavaScript. It's not layout and idle and everything else.
Cool. Yeah, that's really good feedback. I will definitely revisit the naming. I think there is a tendency to treat trace as separate from tracing in the nomenclature, and that distinction should probably be communicated as well in the interface naming. But yeah, Boris, I think that we did discuss potential like future iterations, maybe containing other metadata about stuff being profiled, and in which case, like we could define it to be more general. I have no objections to the performance profiler API name. I think that anyone who looks into it will, as Paul mentioned, figure out that it is a JavaScript sampling profiler. Cool.
Just one comment on the naming. One thing you could do is ask if you have started the tag review.
Yeah, the tag review has finished, but we could probably open up more issues.
Okay, then never mind. I mean, you can reopen it if you want.
Yeah, or just ask for opinions there. They could. Yeah. Yeah, I guess as part of the origin trial, like that wasn't something you gathered feedback, I'm guessing.
We only got, well, I don't have access to the origin trial like survey results since I am a Facebooker. I can ping Nicholas about it. Okay, cool. That would be interesting if there was comments in the survey, but it was mostly just like one conversation with some Microsoft folks where it's like self, and that also resonated with me because like I've never seen self-profiling used outside of this context.
Yeah, I will say I was confused. I wasn't sure which way self meant, and I still maybe am not. Is it a special type of profiling where it's like self-time type thing, or is it that you yourself as the web developer do it, where the name, like the fact that it's an API implies that to me already? It's a web platform API so that you can use it.
Yeah, so it was, there's no special self-time. It's just samples. You derive potential consecutive script execution blocks yourself just from the sample data. I think it's been mostly inertia keeping the name the way it is for this long. Okay, cool. Yeah, I guess I will probably bring it up in the tag thread. But it does sound like there is some interest in maybe keeping it more abstract than just script. And I think something like performance profiler actually appeals to me a lot more because of that.
So Andrew, if we still have a few more minutes on this, so I'm really interested in this. I've been interested since Dominic Cooney, I think, is the first one that told me about it, like 2 years ago, or maybe even 3 years ago. I don't know how long it's been, but it just seems like something that could be pretty exciting for web developers on the one hand. But I don't know. I don't have a good sense of how much a normal, the average web developer would really benefit from this. I mean, I can well understand how Facebook would benefit from it. But I still have this intuitive sense that this could be something really exciting for web developers and useful and help them solve problems. But I have been disheartened so far in that the feedback, it's been a while since I've been paying attention, but the last time I saw feedback from Apple on this, it was not super encouraging in terms of their position about whether it seemed like they would be willing to implement it at all. And I know Yosuke is on, I know Alex is on. It would be useful, I think, to hear from Apple if they're still strongly leaning against not being interested in this at all, or if things have since changed?
Our position has not changed.
Is it? Are you still just primarily concerned about it not like being useful to smaller sites, or that it's
No,
not?
we don't want to add this API because it incurs too much runtime cost.
Runtime after warm-up, or runtime like, because we've noticed that once like profilers are starting, that like it incurs like a fairly minor overhead for actually stack unwinding, and having the UA be able to set the sample interval is part of the motivation to allow UAs like more flexibility regarding runtime costs.
Yeah, I mean, this is not something we would like to implement. I mean, in fact, we will strongly object.
Yeah, I mean, sorry, go ahead.
I just want to, I mean, I trust that your sense of the actual costs about this, you know your engine, you know how that, I mean, it's, well, just step back, it's going to have some cost. I guess the point is that you are confident that the cost is significant enough that it's really a non-starter. There's nothing that could sort of be adjusted. I mean, it sounds like that's what you're saying.
Yeah, I mean, like we're talking about something like slowing the page by 10%. Like that's just not acceptable kind of cost, right? I mean, not to mention the power cost. I mean, what most of the users are most concerned about is like, can I go to the page fast, and does it drain my battery? Like, we're not adding any feature that uses the battery. That's not acceptable.
It's I think the cost equation is more complicated than that, since you can get a lot of signal from a small percentage of users as like somebody who maintains a web property. And with that small signal from some users who, yes, may have their page load times adversely affected, you could resolve issues that can reduce like performance and battery costs for everyone. Like, the idea isn't to have this always on. In fact, that's what motivates the future policy discussion. It's more so just getting enough signal to fix these issues.
Yeah, I understand that, and I would just disagree with that position.
There are also some websites that have fewer users than Facebook.
Right. In which case they wouldn't need this API if they like have a code base that's less divergent and wouldn't incur like runtime costs.
Or, they just enable it once and forget about it.
Yeah, there are a lot of APIs that are foot guns. It's true that this could be a strong one depending on the like implementer, but it's also harder to activate than many other APIs, particularly because we just do require those extra like feature policy headers or whatever activation scheme we need.
Also, the COAP requirement, at least in the short run, is likely to be somewhat of a hurdle for any website that incorporates third parties and cross-origin resources. And one thing, if the concern is around developers setting it and forgetting it, one thing we could do is have some sort of a incorporate sampling into the API itself, so that it will be turned on. Like, as a developer, you're setting a header saying, I want this on 1% or 0.1% of my users, and the browser will roll the dice and include some headers that say whether or not the profiling was on, or if
so that kind of A/B testing approach is not, or sampling is not a kind of approach we're interested in general. Like, we don't do that in our product. We don't want like that, encourage that kind of behavior.
And I don't know that this is necessarily the case for WebKit, but it's also one thing to be aware of. There's probably a non-zero cost to having the code in there at all, even if it's switchable at runtime versus not having the support for the sampling profile code in the engine.
That's true. We managed to mitigate a lot of this because we leverage the existing sampling profiler solutions, which are already like linked in. Okay. Yeah, we have 4 minutes left, I guess. Are there any more questions?
This is Mike again, and at the risk of just, I don't think I'm going to convince Yosuke about anything, but I just would somewhat like to be on the record. I mean, Alex made the comment that not every site has as many users as Facebook, which is true, but there are a number of sites that are on roughly the same scale and that could also benefit from this. But if in the end we're trying to solve problems for actual users of the web, the fact is Facebook is a pretty important application for a pretty huge number of users. And I can say similar properties from other companies, I think, also have that quality as well, that characteristic that they're solving problems for those properties solves problems in user experience for a pretty massive number of users. And so when you're figuring the cost equation, that's something to really consider. That, yeah. But again, I don't have a good perspective myself on weighing that against how much this would help normal web developers and versus the costs for all the other sites that people are using. But it would be nice to see if there's some hope for getting this made a part of the web platform and getting implemented cross browser engine. So I'm going to remain optimistic.
I think it might be something to do with the fundamental sort of difference in approach in POF, right? Like our approach in performance engineering is not about letting websites optimize for our engine. We optimize our engine for like content out there. So I mean, it's sort of like a chicken egg problem, because if the engine is slow, website wouldn't use it. We wouldn't optimize. But I think what somebody saying something in a comment. What are they saying? Should be suffering from living testing from low progress. Yeah. So I think, I mean, it really. We just don't really do this kind of testing in general in our product. So like that's also maybe the physical difference, right? I mean, I understand that websites do A/B testing, right? That's not simply a thing we do. Like we don't want that. We don't want users to be tested, we don't want users to be sampled. So
if you're speaking in the context of having the user agent control the activation threshold, I think it could be suitably reframed to not be considered an A/B test sort of distinction, and more so like I am granting the site this much resource to gather signal on performance stuff.
Right. What I'm saying is that we don't want to do that, right? I mean, it doesn't matter how you frame it.
Which is your decision. Yeah. I can just speak from like a product point of view. It's like we found this like to be massively useful.
It would be useful for us as well at Wikipedia, because we're dealing with a lot of variations in the JavaScript that individual users are running. We even have the ability to let users write their own JavaScript on the site, which is something fairly unusual, which means that depending on which article you're looking at and which type of user you're looking at the page, you'll be running very different JavaScript. And so it's very difficult for us to find those user scripts or wiki-specific scripts that are causing issues without something like this that allows us to sample like very random pages and discover things that were just invisible in the global picture of even looking at long tasks because it just can't find patterns easily. So that I think for any website that's dealing with this type of different users get different experiences in ways that it is very difficult to monitor at scale, it could be useful even if you're much smaller. It's more a question like a website that serves the same experience to everybody doesn't really run into that problem, as in they could solve it with local profiling. But as soon as you start serving a lot of variance to a lot of people, then you run into issues where this is useful.
Yeah, and I think Wikipedia is another good example of a website that can abide with the co-op and co-op restrictions due to lack of third parties. So thank you. That's a great example. And
great feedback.
Yeah, and with that, we're at time. So thanks, Andrew, and thanks all.
Thank you.
Yeah, and we will see y'all tomorrow for the last day of TPAC. So, cheers.
Thanks, everyone.
Bye.